During the 15th and 16th centuries in Bohemia, campaign weapons were developed for real combat. The dusak was a robust sword with a curved blade and greater mass toward the tip, allowing powerful cutting blows. Inspired by this context, we created Polní Sekera, Bohemian field axe. Polní Sekera is a Czech term meaning field axe, representing our modern interpretation focused on function and effectiveness. The safety equipment used included a welding helmet, safety glasses, welding gloves, and a leather welding apron. Safety was treated as a fundamental part of the process, ensuring proper protection at every stage of fabrication. The sword was forged from automotive scrap steel, which was later characterized through chemical analysis and metallography. The material was identified as a medium carbon alloy steel, showing microstructural changes after heat treatment, including martensitic and air-cooled structures. This analysis allowed us to understand the relationship between composition, heat treatment, and mechanical behavior. Our learning curve wasn't a straight line, it was a free fall into reality. On day one, textbook theory collided with the heat of the forge. We quickly realized that memorizing the iron-carbon phase diagram doesn't teach you how to swing a hammer. Our first strikes were clumsy, all brute force and zero technique. The improvised anvil was unforgiving. Every poor strike sent a painful shockwave up our arms, a stark reminder that engineering is physical, biological, and painful. There were moments of genuine frustration. The heat was stifling, and our arms trembled so violently that we had to learn to blindly trust the teammate taking the next shift. But within that fatigue, we found a rhythm. We stopped fighting the steel and started listening to it. We learned that knack is just applied physics driven by intuition. We didn't just forge a sword, we forged team resilience. There came a point where mental exhaustion outweighed the physical. Maintaining high alert in front of 800-degree metal, ensuring you don't burn yourself, crack the blade, or hit your friend is draining. Our operator rotation sounds highly technical on paper. But on the workshop floor, it felt like survival. It meant looking each other in the eye and admitting, "I can't go on, you take over." That radical honesty was our most effective safety tool. Our instructor, while not an old master, was our anchor. We learned together. When things went wrong, we didn't look for blame in textbooks. We looked for solutions in the fire. We discovered tricks to rest our muscles without letting the workpiece cool down. Practical hacks that aren't found in manuals, but are what ultimately saved the project. As the project progressed, we realized that success didn't come from doing everything the same way, but from allowing everyone to contribute differently. Some of us discovered a genuine passion for forging itself. The physicality of the process, the rhythm of the hammer, and the direct interaction with the material made it clear that this was something we wanted to continue exploring beyond this project. Others found their strength in understanding the material from a different perspective. Metallography, microstructural analysis, and heat treatment evaluation became the way they connected with the blade. Studying the steel after forging gave meaning to every step taken at the anvil. There were also those who focused on design, planning, and organization. Defining geometry, sequencing operations, managing time, and coordinating the team turned a complex idea into a workable process. Without that structure, the blade would never have existed. What truly defined this project was that everyone participated. Forging a sword is not a single task, but a system made of many disciplines working together. Each contribution, whether in the forge, the lab, or the planning stage, shaped the final result. By the end, the blade became more than an object. It became proof that engineering is collaborative. That learning happens in many forms, and that growth often comes from discovering where you truly belong within a team. In the end, we didn't just produce a blade, we produced understanding, commitment, and respect for the craft. And that is the experience that will stay with us long after the forge goes cold.